Hello everyone, I am Ron and I am the game design instructor for the Academy of Entertainment Arts over at Dixie Hollins High School. If you are one of my students, it's Mr. Flowers to you, and welcome to this video tutorial. Hello everybody. Today in this tutorial we're going to look at artificial intelligence. And when we think about artificial intelligence, we tend to think of like, Terminator or I don't know, some sort of intelligence a lot like us in terms of the way we think and memory and all that good stuff. But in terms of gameplay, artificial intelligence is really about simulating something being able to negotiate the environment that you put it in. And that's really all the intelligence is. Even with us in the real world, our intelligence really has to do with how we understand what to do in our environment. And it's really not all that difficult to set up. Sure, artificial intelligence can be a very complex thing if you're trying to reach like Terminator 2 kind of levels here, and as far as thinking. But as far as gameplay goes, you don't have to be too complex. So I went ahead and set up this demo for you so you can see just what we're going to be doing. This is the room transition piece that we've been working on the last few videos, and of course I have my player, and here's my little guy here that does his own kind of negotiating. So you can jump over stuff, you can look around, figure out where he's at, not bounce off the walls, and if he gets into a position where he's stuck or whatever, he'll figure out that he's stuck and go, oh, okay, well I'll move away. So this is really all we need for basic artificial intelligence. You can do more complicated things, but for this will work. I'm going to go ahead and exit this, and I'm going to jump into the room transitions piece here. And if you have this from the previous video, just go ahead and save this out. Go do like a file, save as, and I always recommend saving stuff out as other pieces. So you can do, like I have one here ready to go for room transition for AI practice 2 or whatever. So just go ahead and save over this one. And we are ready to go. So what we want to do first is create a character. So to not be too complicated, let's open up our sprites, and we have our player sprite. I'm just going to duplicate that. So duplicate. And I'll go ahead and rename this. This is going to be SPR_enemy. And I'll give it a different color, just so I can identify it. You can pick whatever color you want. Enemies are usually mad at you, so I'm going to go ahead and make them red. And I'm also going to give this guy some basic animation so you can see when he's moving one direction or another. So I'm going to put a little arrow on him. So I'll grab my little triangle here, I'll pick a different color. And on this frame, I'm going to do his left position. That'll work. And confirm that. And now I'm going to just duplicate this, so copy it, paste it, and image. We'll go down to mirror and current frame. So I'll just move that one over. So this is my left frame, this is my right frame, and that's all we'll really need so we can tell which way he's going. I'm going to come down to our objects here, and let's see. I'm going to go ahead and create a new object, so create, and I'm going to call this one object enemy, so obj_enemy. Now we're at sort of a point where we should probably start categorizing our objects and things so they're not all cluttery. Like this would be like under player stuff, this should be like level stuff, whatever. I'm going to just move this up under player here, and I'm going to call this, it's object enemy, and I'm going to give it a sprite. And like anything that we're creating for an object, we usually need a create event, so go ahead and create usual stuff. So I could type variables. And whenever we're moving something, we have to set up some basic movement code. So in this case, just like if we were moving a player, we have some basic stuff. So if I open my player, we can look inside here. And we really could just copy this verbatim, right? So we need our velocity x, our velocity y. In this case, our character can move at general speed, so he would have a move speed. He can jump, so we should have a jump speed, and it is controlled by gravity, so I should have a gravity thing in here. So I'm going to go into my object enemy, and we can just copy this out of here. Good deal. So velocity x, y, movement stuff. Now you don't need to do velocity if you are just going to update the x and y positions directly, but in this case, since we want some sort of acceleration, it's probably better for us to do it this way. We're going to add an event. We're going to do a step event. And this is where we're going to get into the basic movement stuff. So we're going to do update enemy. So if we look at our player, go into our basic movement code, we have a condition where if we push a button, we can move the character to the left. So a negative move speed moves to the left. If we push another button, we get a positive move speed, and that moves us to the right. And if we're not pushing any button, we stand still. We go to an idle position. Right? Well, setting up the autonomy for an object in a game is done pretty much the same way. The difference is we're not going to be controlling it with a button. We're going to be controlling it with some sort of toggleable action. What I mean by that is we're going to set up like a state machine, and that state machine is going to determine what the character is doing at what moment in time, and we're going to have it make its decisions based on a timer. It's going to have a timer that's always going, and when it reaches 0, it's going to make a new decision, and then it's going to do something based on that decision. So if we jump into our object enemy, first thing I want to set up is the same thing that we have in our player. If I go back to here, we have this piece that's just saying object, if the game is in the game state, then we're going to do some stuff. And I want this piece here just so that when we start the game, the character's not already doing something. So I'll go ahead and add that piece here. So I'm going to do if, center this up, if object game dot state, we're going to say in game we'll say do stuff if the game is running. Sure. So once the game is started and we're in that particular state, we need to get the character's movement. So same deal, we're going to have our X and Y location modified, but we need a state for our enemy as well. So I'm going to go up here to our create event, and I'm going to break off a new spot. I'm going to call this state, and I'm going to go ahead and set this to some value. Now, if you remember from any of my previous videos, you can set this up using like an enum, you can set that up using values of some sort. GameMaker lets us get away with just writing to strings, so I'm just going to create a string, and I'm going to do idle. So whenever my character's state is in idle, he'll be standing still. So we'll do a switch. And the cool thing about switches is you can set them up sort of like an if statement without having to do the whole if, this, and that sort of deal. You can just change the switch value, and you get a new thing. So we'll do case, we'll do idle, colon, and we need the break. We always need a break inside of our case. Alright, so here's our case for idle, here's our break. If we're in the idle case, are we going to be moving or not? Well, the answer is no. So we'll just say stop moving. And then our velocity x will be 0. You can set a velocity y value here to be 0 as well, but if you're falling, then your y value would be updating. So most of the time you don't need to put a y value in here, but you can check it if you need to. So that'll be good for our idle state, but now we need to set up our movements left and right. So we're going to do case, I'm going to call this one move left. And you can do this again, you can always do like camel case, you can do underscores, whichever. Doesn't really matter. Add our break. Always got to have a break in there. And we're going to call this, the first part we're going to do when we start to move left is we're going to change what sprite's being generated here. So we have our sprite and we have the little arrow that moves left. So I'm going to say change image. So image index is going to be set to our left image. In this case, that should be image 0. So I'm going to go into here, set this to image 0. And then the next thing I want to do is move to the left. So Vx is going to get a negative move speed. Next thing I want to do is set up my move to the right. So I'm going to do a case, and this is going to be move right. Again, we need our break, and it's going to be the same code as before. We're going to change our sprite image, and we're going to move the other direction. So first thing is change image. So image index will now be set to 1 because that's the image that we have set for that. And then we're going to do move to the right. So Vx is equal to a positive move speed, and that will allow us to move to the right. So if we're in idle, we're going nowhere. If we're moving to the right or moving to the left, we're moving left. If we're moving right, we're moving right, and so on. Okay, and that should be good enough. We'll set up a jump in just a minute. We're going to exit the switch. So if we take our little brace here, so the end of the switch is this blue one right here. I'm going to come outside of the switch, and we're going to set up the collision code and all that good stuff. So we're going to say usual stuff like place meeting, all that. So I'm going to steal that from the player so I don't have to retype it. So I'm going to go to the player, step event, and if I scroll down, you can see we have our jump code, our gravity code, and our horizontal collision left and right movement. I'm going to steal this. I'm also going to steal the gravity. So I'm going to go ahead and grab everything from our gravity, this piece, all the way down to this Y part right there. Now you hear me say all the time, don't be a copy paster, but we've written this a few hundred times, so this is nothing new. I'll go ahead and jump into here. And all we're doing here, this is the same kind of code we use for a player for we're checking if we're colliding with the wall or something. We don't want our enemy to fall through the wall. So I'm going to go ahead and paste this right here. Go ahead and title the gravity piece gravity. Then we have a horizontal movement, and so on. And then above my gravity piece, but below my switch. So here's my switch. You can see if I highlight the brace, that's the end of the switch there. So above the gravity, but below the switch, I'm going to start checking for some sort of activity for the bot. So I'm going to write a timer. So I'm going to say, in this case, I'm going to do timer minus minus. And all I'm going to do in here is I'm going to say if timer is less than or equal to 0, then I'm going to reset the timer. So open some braces. So timer is going to be equal to, I'll pick a random range. So random range. And we'll give a couple values here. You can put, you can see of an x1 and x2. So we are starting a possible small value and a possible large value. So my minimum, I'm going to say, is 1 step, which is 30 ticks. And then, or 1 second, which is 30 steps in this case. And I'll do 90. So it can be anywhere between 1 to 3 seconds of time could elapse before a new action takes place. And then I'm going to have down here, I see our state, because this is the thing that our character has to be in order for some action to happen, right? So our state has to change to either idle or move left or move right for him to do something. So I'm going to have my state set to choose. open brace, and you can see down here you have x1, 2, 3, or 4. This can go on to up to 16 choices. So I'm going to have it choose between being idle, so idle, comma, move left, move right. I don't have jump in here yet, so I'm just going to go ahead and close this off. And this will give us a basic moving left and moving right kind of setup. I also have to create my timer. My timer has to be created in my create event. So whenever you add a new variable, make sure you add this. I'm going to go under my state here. I'm just going to do a timer. And same deal here. I'm just going to do the same thing. So random range, so it seems kind of natural. I'll do a 30 and a 90. You can make these anything you want, but this is what's going to work for me. And then lastly, I need to add him to the room. So I'm going to go open my room here. And let's put our player, or our enemy, into the room somewhere. So I'll put him here. Now if we play the game from here, our character will walk around, but our character will fall out of the level. We don't really want him to do that. So for the moment, let's put some blocks around the door here, just to keep him safe. He can't reach this yet, but eventually he'll be able to get there, so we'll just block that off as well. And to be able to see him, because we have our camera on, we won't be able to see him over there, so let's go ahead and turn the camera off. So I'm going to come over to here, Properties, and then View, Cameras and such. I'm going to disable my camera, and I will not clear the viewport, and I will disable this one as well. So I'm going to uncheck these three. That way I can have a much wider view and see what my character's doing. So go ahead and play that. And there we have it. We have a very basic, he's going to move and do whatever. So this little ticking where he's like switching back and forth, that's him in his idle state. And you really can't tell that he's idle because the animation's going on. And there he goes out the door. But luckily we put that wall there so he couldn't fall out. And there we go. So he's going left and right, and he stops and he moves. And that's very basic artificial intelligence. We don't even need him to do anything else. We could play the game and have a few of these walking around and doing different things, and it would give the game a sense of autonomy. But we're going to go a little bit further. So let's go ahead and exit this. Go back to our enemy object. And we're going to do a couple things. In the create event, we're going to stop that flipping around. So to do that, we're just going to tell the image index to, or the image speed to be 0. So image speed will be 0. So he will no longer do that flipping animation. The next thing I want to do is I want to create an output to the screen to see what state my character is going to be in. So let's go to Add Event and do a Draw Event. And we're just going to draw this at the location of the enemy. So I'm going to do Draw Debug Info. And if we're ever using a Draw Event on a object that's in the game, you always want to make sure to use the Draw Self script first, so draw self. Because if you don't, you won't see them. And now we're going to do the output of stuff. So I'm going to say draw text, the X location of our character, which is should be in the middle. So if I open this up, it should be drawn middle center, and it is. So the X location of our character, the Y location of our character, and then this is going to be the state. So I'll put a little space there. So I'm going to do plus string. I'm going to convert the variable to a string here. And just do state. Close that off. So this will report the state that our character is in to the screen. So if we go ahead and play this, we'll see that on our character. So there is his state. You can tell that he's in the idle state. Now he's moving left. Now he's moving right. You can kind of see the decision making happening in real time here. Okay, let's report some other things to the screen. Let's move this up a bit. We're going to do, our character is 64 by 64 pixels, or sorry, 64 pixels tall. So if we move this up, say 34 pixels, it'll start at the top, and then we can kind of list some things down. So that's what I'm going to do. I'm going to move that to the top of him. So I'll do minus, so that's his Y position going up, 34. And then I'm going to take this, I'm going to copy this piece, and we're going to do the next one down. So 34, and I'll do 10 down, so 24. And this will be the timer. Change that to timer. We'll be able to see his thought process ticking as we go along. So go ahead and run that. So there we go. So as the timer counts down, it gets to 0 and a new decision will be made. And you can see that it gets a different time every time. So it chooses between 30, anything between 30 and 90 seconds. So he chose to be idle again, so that's okay. And he's back there in the corner. So let's stop our little bot guy from going through the door, because we don't want it to appear, I mean, I don't want it to appear, you could always have that, but I don't want him to look like he's going through the door, because I'm always thinking he's going to get lost. So let's modify this just a little bit. We're going to go to our objects here and just do a create new object. We'll call this obj underscore wall underscore parent. And we're going to give this wall parent to our wall and the door. Okay, so I'm going to open up the wall, and our parents list here, we're going to assign it to the parent of the wall. I'm going to do the same thing to the door, give that the parent of the wall, because our door is going to act as a wall as well. And the way parenting is going to work is we're going to tell our enemy that if it ever runs into a wall parent, that it's going to stop moving. So these being the children of the wall parent, you know, if you run into the children, the parent's going to yell at you and say, don't do that, right? So, so parent, go ahead and change these. So wall parent, parent, and parent. We don't have to do that to the player. We only care about the enemy, because the enemy will run into the door, and that should work. So that'll keep him from going outside the room. Here's walking. And of course he can run to the door. He doesn't go through it anymore, which is awesome. So there you go, basic left and right movement. But what if you wanted something more than just this? What if you wanted him to be able to jump or negotiate some areas? Well, then you have to give him instructions on how to do that. So for example, let's say we wanted him to have the ability to jump. Well, let's go into our code here, and in our state machine, we can say, well, we have idle, we have move left, and we have a move right. Let's create a movement for jumping. So we'll say case jumping. Give it a break. Now, if you had a jump image to go here, you could change the image to jumping, but we don't really have one for this case, so I'm not going to write a new image. I'm just going to do jump if allowed. So I'm going to do if not is jumping. Create a new variable here. Then is jumping will be true, and our velocity y will get a negative jump speed. I'm going to go ahead and copy this. I'm going to do a falling one as well, just so jumping and falling are two different states. Go ahead and paste that in. I'm going to change this one to falling. Now for our falling animation, we don't really have any animation to put here, and we don't really have any actions to go here. So for the moment, this one's going to be blank. I'm going to put a little comment here. no fall animation yet, but it's okay. When we're in this state, he won't be able to do anything until after he's done falling, so it's fine. I'm going to come down here. Now we're going to add a condition that allows the character to jump. So let's set our jump value inside of our create event here. You always want to do that, so we'll do is jumping. We'll set that to false because we're not when we start. We'll also set up a variable for is falling. We'll set that to false because we're not falling when the game starts. And we'll be able to toggle these on and off and see if they're running. So under what circumstances would we like our character to jump? Well, we only want him to jump if there's something in his way, right? Or if he's following the player. We could say if the player's jumping, then maybe we're jumping. So we'll do that first. So I'll come out to so I'll come in here under gravity. So I'll do if the player y is less than our y, because a negative value is up and a positive value is below. We're going to do state will be set to, if I can type here, jumping. And we'll see how that works. Okay, so now if we jump, you can see he does a jump. Of course, he only jumps once. And the reason he only jumps once is we have a variable being set that checks if it's okay to jump, and that gets turned off after it's set. So like from here, we go to our jumping state, and we are allowed to jump at that point. We turn jumping off. This is just to prevent him from jumping multiple times in the air or whatever. You can turn that off if you don't want it in there. So we'll come down here and we're going to say vertical collision and movement. And we're going to set this up so that we can jump. So after we hit the ground, we're able to start jumping again. So let's make a new spot in here. We'll say if our velocity y is greater than 0, that means if we're moving down, I'm going to wrap this collision piece. So if our velocity y is greater than 0, so if we're moving down, and then we hit something, we've hit the ground, and we are no longer jumping. We'll say after this y value, we'll say is jumping, and that's going to be false. However, we can hit the ground if we are under other circumstances as well. So, for example, if we're in the air and we hit the ceiling, then we really can't jump again. So you could have an else here and give an open brace, closed brace. We'll just copy this piece into there. So in this case, we can put a little comment. So we'll say if moving down, and this one could be if moving up. So if you know what both of these are doing. So if we're moving down, there's a collision, then our jumping value is false, and we're allowed to jump again. And then if we're moving up and we hit something, we're just going to stop moving. And then, of course, if we're moving down, or if we're moving up and we hit something, we're just going to stop. Okay. Now we do want to trigger that we're falling if our velocity is a positive value. So we're going to come up here to, I guess anywhere in here is fine. We can do after the gravity. Say, are we falling? And I'm going to say if your velocity y is greater than 0, then yes, you are falling. So falling would then be true. So is jumping would be false. We're no longer jumping if we're falling. Is falling would be true, and we would be in the state of is so falling. Now you could do this here if you want to make this feel like it's being useful. You can put this trigger inside here, and then you'd be like, oh yeah, it's true. But whichever, this will work. So if I jump, he can jump, and he can continue to jump whenever I jump. So right now, he can keep on going. Technically, he's colliding with the wall over here and is able to jump off the wall. But now he's not able to exit our fall animation, stuck or whatever. So let's go into here, and we have our timer. And we're going to have our timer set to only really tick if we're not falling and not jumping. So we'll say if state is not equal to our jumping state, or our state is not equal to our falling state, then we'll run this timer, and this timer is what allows us to change what we're doing. Right? So we don't really want the player or the character to be able to necessarily move while he's falling or whatever. I guess you kind of could let him do it. It wouldn't be too bad. But we also don't want to go idle while we're falling. Okay. And if we hit the ground, we're also no longer falling. So go ahead and add that in here. So is falling be false. And actually, as I'm thinking about this, we really don't need our is falling check. So we're going to take that off. I actually don't need it. Sometimes I get redundant. We really don't need this part. So we'll take the is falling, because we're not running anything to check that. We're just going to pass it to the state. That should be fine. I'm going to go back to my create event. We're going to go ahead and snip that off. But we will need to move this piece. If we run this, so we have our gravity checking before we fall. And this is always going to set us in a state of falling. So if we run this, we're actually going to see that. We're going to be in perpetual fall if we run it. So you can see the guy there, he is perpetually falling. And the reason for that is, as this is passing, it's going to run the gravity check, and then it's going to check our current velocity. We want it to check the velocity before it checks the gravity. So we're going to move this. I'm going to go ahead and Control X that. I'm just going to move it above the gravity piece. So now it'll check our velocity if we're falling before it checks the gravity. So it checks, are we going to fall? Then if so, then we're going to move this. So now we will no longer be in a perpetual state of falling. There you go. So he's back to idle. Of course, we jump, he can jump, and he can walk back and forth. Change the decision. Boop. Now, it does take him a while to make a decision if he's up against the wall, right? So we want that to be a little bit more lifelike. So if he hits the wall, we're going to make it so that he changes direction immediately. Go ahead and exit this. Don't forget to put a little caption on our if we're not jumping or falling. So I'll put if not jumping or falling, then run timer. And you can call this like decision timer or whatever if it makes it help your brain a little bit. Okay, so we want to make it so that whenever we hit a wall, we will automatically turn around. You can do that inside of your place meeting event. So when you hit a wall, did you hit it or whatever? But instead, I'm actually going to use a position meeting. And the difference between a position meeting and a place meeting, if we hover our mouse over and just kind of middle mouse click, you'll kind of see the difference here. So place meeting, if we read up the code here, what it does is it takes the boundary box of your character and then the boundary box of the object you're going to hit, and then it checks to see if there's an overlap. And then what it does, if there is an overlap, is it moves the two apart from each other and then says, yes, there's a collision. This is a little bit slower to run, And if we're checking through like all the wall objects or whatever, that can take a while. So instead, we're going to do a position meeting, which is a bit faster. Let's go down to our collision checking here. And simple collision. You can also do a place empty. You can do that as well. We'll do a position meeting here. And this one just checks Now when this function checks if another instance or all instances of an object. So it checks against all of them. And when you are checking a single point in the room for an instance, this check will be done against the bounding box of the instance or against the mask of the instance if that instance has precise collision checking or whatever. This is a little bit faster than place meeting. So let's go back into our enemy here. And after this part about the player, I'm just going to make a spot, and I'll title this. I'll say jump if player jumps. Jump if player jumps. In this part I'm going to do, can I move left? So all we're going to do is check if we can move left. So if position meeting, our x location, and remember our x is actually in the center of our characters. If I come up here, our x is in the center. So we're going to see if some distance ahead of us there's going to be a collision. And again, you could use the position empty function to see if there's anything there. It'll work just the same. But I'm going to use position meeting, and I'm going to subtract a distance ahead of my character to the left. So by hitting a minus, I'm actually moving to the left of my character. And I'm going to say I'll do like 20 pixels to the left. So if there's some distance to my left, there's an object, I'm going to move the other way. And then my y value doesn't matter in this case. And then I want to check against the object wall parent. So obj wall parent. So go ahead and do that. So then in here, I'm going to have it say, if we're moving to the left and we hit a wall, we're going to immediately move to the right. So our state will then be set to move right. Now we don't want to just hit move right without doing anything else, because we also have this decision-making timer going. And this timer is going to be ticking even if we hit that wall. So we don't want to hit it and then move right and then the timer to run out and then immediately change our decision. So we're going to tell it to reset the timer. So in this case, I'm just going to reset the timer. So timer, and that's going to be random range between 30 and 90. So we'll just reset our timer. And we can do the same thing for moving to the right. So let's go ahead and test this one first and see what happens. So he's sitting there idle, moving to the left, moving to the left. Might take him a minute. So moving to the right, still getting hung up because we didn't put the code there yet. Let's see if he'll go left. Will he go all the way left? And then he hit the wall and he immediately turned around. Boop. Okay, so we'll do the other side now. So I'm going to go ahead and copy this. And just underneath that, I will paste it, and I'll say, can I move to the right? So I'll say right, and I'll make this one move left. So now, since I'm moving to the right, instead of doing a minus 20, I'm going to do a plus 20. So plus so many pixels. You can check further ahead, but I find this to be a good value here. So now if you hit something left or right, it will immediately change and not be hung up for a while. So a little bit here, stop, a little bit there. Boop, and he changed. Boop, he changed. Okay, so it looks a little bit more like something that's living and making some decisions in the world, right? So what if we made this a little bit nicer to where instead of just jumping when the player jumps, that it jumps when there's an obstacle ahead of it. So let's go ahead and do that. Let's put a little wall in front of our enemy here. So I'm going to take this wall piece that's right here. I'm going to go ahead and stick it down on the ground right about there. That should be fine. I'll move him back a little bit. And I'll put a couple here. So I'll just use this wall piece. I'll do that. I'll make this one taller, and I'll make this one really tall. There we go. So that gives him like an obstacle to sort of negotiate. Now we know that if he hits it right now, he'll just change his decision and go the other direction. But we want him to jump over it. So what we can do is in here, instead of doing a check for jumping when the player jumps, we're going to check to see if there's something in front of the enemy, and then if there is, he'll make the decision to jump. So for now, I'm going to turn this piece off, this jump if player jumps. I'm going to go ahead and comment that out. But what I will do is I'm going to come down here. So after my move to the right, I'm going to make a new spot. I'm going to have this say jump wall to the left. So if there's a wall to our left, we're going to jump it. We're going to use a position meeting again. Again, you can use place meeting or position free, but whichever is fine. If position meeting, and I'm moving to the left, so my X value, and I'm going to check some distance to my left. So each one of my blocks in this case, they are 64 by 64. So to not get hung up on the block, I want to make sure that I have enough time to anticipate whatever is ahead of me. So let's try this. We'll do 64 pixels, and then our Y value, and then obj underscore, we're doing our wall parent. I'll just go ahead and close that off. And inside of here, we're going to do our state, and that's going to be set to jumping. Now you might be wondering, should we set our timer again? And the answer is no. The reason we're not going to set the timer is we actually have this piece up here that says if we are not jumping or falling, we will run the timer. So as long as we're in a jump state or a fall state, the timer is not going to run. So a decision will not change until we hit the ground. So we should be able to jump if there is a wall object to our left. However, it's always going to be checking this. So we're probably just perpetual jump, and you'll probably see that in just a second. We'll see what he does. So there's a wall to our left, and we got close to it, and now we're jumping. And you can see he's perpetually in a jump because this wall is always going to be here. So what we can do is we can set up a few conditions. We can set up a condition that checks for us to jump only if we're moving, because we need to have that momentum to get over the object anyway. And we can also have it check if there's a position free above us. That way we're not just jumping arbitrarily. So we'll do that. We'll say inside of this if statement, I'm just going to put in a new thing. So we have if, and before the position meeting, I'm going to do our velocity x we'll say is less than 0. And the reason for that is a value less than 0 will have us move to the left. And so both of these will have to be true. So if I'm moving to the left and the position next to me is going to be a wall, I'm going to jump. You can also use, if you don't like using the ampersands, you can use the actual word and GameMaker will figure that out for you. But I prefer the old coding method here. So and position meeting, we're going to do a jump. But we also want to check if there's a position above us that is available. So I'm going to also check. So I'm going to say after this position meeting, so at the end of its parenthesis, I'm going to do an and as well. And I'm going to do position meeting our x location, and then a y location minus a certain amount. So however many pixels above us. Well, that'll be 64 because the block above us is one block. And then we need our object wall parent. I'll add another parenthesis there. I'm going to go to where this little and is, and I'm just going to hit enter, and that's going to snap this down. So my if statement was going to wrap here. So if this, get to the end of that, and we get to here. If it helps your way of thinking, you can leave the little and symbols over here, and it'll let you know that you can come down, but whichever, that's fine. And then I want one more position to check. So this will work, but I also want to make sure that we're looking ahead of ourselves in a corner position so that we're not just jumping randomly. So this will check some distance ahead of us and get us to jump. This will tell us that if there's nothing above us, we're allowed to jump. And we also want to make sure that the corner block is not going to be in the way as well. So I'm going to do a little and here. Go ahead and break that off. And I'm going to say position meeting x minus some distance, so I'll do 64, and a y minus 64, and then our object wall parent. So those are the three things we're going to check, or four things I should say. So if we're moving, and then some distance to our left and above us. Well, we want to check if there's nothing there. So in front of this guy, we want to make sure we have a not symbol, so a little exclamation point, and then one here as well. So if there's not something ahead of us and not something to the corner. So there we go. He's trying to jump. But he's getting hung up on this. You can see that he's starting to jump, but then the bottom end, he gets snagged right there. So he keeps looping. It's like, well, I can't get there. So let's make it, instead of on the x value here, on this little x value, instead of 64 pixels ahead, let's give him enough distance to clear it. You can do like 50 pixels or whatever. I'm just going to do 2 blocks. So I'll say 128 on this x value here. And then down here on this position meeting, this x where it says minus 64, I'm going to do that one as well, 128. Make sure you're doing the minus x value and not the minus y value. Okay? Be aware what you're messing with. And that should give us enough distance to clear that block. Boop. Look at that. He's able to negotiate those and get over that. Yeah, he is kind of cheating by doing a double jump, but I'm not going to worry about it. But he is running into this problem here, which is he doesn't know that he can jump the other way. So let's go ahead and allow him to jump the other way. So I'm going to go ahead and copy this piece, make a new spot, paste it, and we're going to be moving to the right. So our velocity x is no longer going to be less than 0. It's going to be greater than 0, so we'll change the sign. And then here, our x value is going to be checking to the right of us, so it's going to be x plus 128. Our y value on this next line here, the position meeting x y minus 64, that's going to be the same because we're still checking above us. And then the not place meeting x minus 128, that'll be a plus 128. And then the y, once again, will be checking above us, so that's still going to be negative there. And that should allow us to jump both left and right. Alright, so let's see what happens. So there he can clear that. And yeah, he does cheat by double jumping, but that's fine. And then he's able to jump both left and right. But now we have a situation where he is unable to jump out of this pit. He's kind of stuck because he's told that he's not allowed to jump if there is a block in a position just above him. So if there's 2 blocks high, he can't jump it. So he's like, well, I don't know what to do. I'm stuck. So I'll just keep trying to go left and right because he's told that if he touches a wall to go the other direction. So he's in a perpetual I'm stuck in this position. So we need to do a situation, or we need to set up a condition that checks if he's stuck in a loop and to just have him jump out. So to do that, we're going to have to do a little bit of a trick here. We need to set up what's called an array, and we need to check our last action. In our create event here, we'll say check last actions. So the first thing in our system here is going to be a current action. So whatever our current action is, that's going to be whatever the state is. Then we're going to have a action timer. That's going to have some default value. I'll give it a value of like 6. It doesn't matter. It's just however long it's going to take to count this thing down. Now we want an action count. So how many actions are we going to count before we decide that we've done something too many times? So I'll do action count, and I'll set that to some value. You can pick whatever. And now I'm going to have the actual array. So my array is going to be called last action. And I'm going to put some brackets on here. So all an array is a variable that has multiple indexes. Okay, and by putting these square brackets on here, we're telling GameMaker or any programming language that this is now an array, and there are multiple instances of last action. In this case, last action could be expressed by a number. So you can put like 5 or 0 or 1 or whatever. But whatever goes in here will define the scope, or how big this array is going to be. To do that, I'm going to want to use a loop. I could do it by hand. I could say last action 0 and then give it a value of some sort, and last action 1 and a value. But that's kind of redundant. It takes too much time to set all those in individually. So we're going to use a loop to do this for us and do all of our counting. So inside of here, I'm just going to put a random variable. I'm going to call it n. And I'm going to set this to none for now. So none. But before this can take place, I need to have a loop to step through all of the possible values. So all n is some number that represents the ID for last action. So n could be 0, 1, 2, 3, 4, 5. So I'm going to have a loop. It's going to say for, and I'm going to create a volatile variable, so var n. So this is where n is going to come from. We're creating the n as part of our loop here. We're going to set that number to 0, so that's where it's going to start. The first index of the array is 0. And we're going to say as long as n is less than our action count, so however many actions we're allowed to have, n is going to step through each action and update the ID of our last action. And then n plus plus. So when this is first created in our create event here, it's going to set every instance of last action. In this case, we have 5 instances of them because we have an action count of 5. So for each instance of this, they will all be set to none, and we'll be able to see that displayed on the screen here in just a second. So I'm going to come over to my draw event here, and let's make a new spot, and we're going to use our loop here. We're going to just call this display actions. I'm going to use the same loop again. So I'm going to say for, and then my var n. That's going to be set to 0 because that's where it's starting. So we're going to start at 0, and then we're going to say n as long as n is less than the action count, n plus plus. We're going to step through each instance. Then we're going to draw some text to the screen. This way we can see what's inside of each one of those boxes. So x and y. And we want to see a new line for each one of our boxes being drawn. So I'm going to say y, and the top of our list is 34, so I'll say y minus another 10, so I'll say 44. And then what I want to do is I want to subtract the line that each new instance is going to have. So every our text is about 12-point font, so every 10 or 12 points we want a new line. So I'm going to say subtract. I'm going to use parentheses here. Inside of here, I'm going to do a little bit of math. I'm going to subtract the value of, we'll say, 10 pixels multiplied by the current value of n. So it's going to start here at 44 pixels above here. And then it's going to say subtract 10 pixels for the value of n. So if n is the value of 0, then 10 times 0 is 0, so we're just going to be minus 44. However, if n is 1, then 10 times 1 is 10, so we'll be 44 minus 10, so that'll put us at a negative 54. If n is the value of 2, then 10 times 2 is 20. Minus 44 minus 20 will put us at a negative 64. And so on. It'll do that for every instance of n. And now I'm going to put a little comma here. So this is our y value. That all fits in our little y value spot, right? Now we want the string. What are we going to report to the screen? Well, I want to see each one of our actions. So this is going to be action, or I'll say last action. And then I'm going to put a space. I'm going to say plus string, and then I want my array. So my array is called last action, last underscore action, and then I need to put my square brackets. That tells GameMaker that this is an array. I need to make sure that my variable n is in here. This is going to be the number of the array. So for each one of these, it's going to draw a new one. And then I'm going to close that off, and then semicolon. So now when I run this, you will see all the actions drawn to the screen. So go ahead and run that. They all should be none by default. And there they are. So there's the character, last action. You can see that they're all set to none. And they step up from the last position, which is right there. But it would be nice if we saw the ID of each action, right? So what we can do is we can tell it to report the ID of each action after the word last action. So to do that, I'm going to add right here where this little space is, I'm going to add an open brace. And this is a little bit of a trick. This is called concatenation, where we're going to add a piece of a string to a piece of a string. So the way we're going to do it is we're going to use this little plus sign here. And in the code, we're going to say plus string. And then in here, we are going to do the value of n. Okay, so this will tell us whatever the value of n is. And then we're going to add a new string. So plus, and we're going to actually put an actual string here. And we're going to put the closing brace there with a space. So it'll give us, so what it'll look like on the screen is, I'll show you in just a second. And then after this one, so we have an error, we need to have another plus sign. So we need to add that part of the string to it. So it'll take this part of the string, it'll then add to the string this value, and then it's going to add to this string this character, and then it's going to add to the string this value. And it'll look like this on the screen. So you'll see on the screen, you'll see last action, and then some number, and then whatever value is in there. So in this case, it would be like none. This is what you'll see on the screen. So you'll see this part of the string and this brace, and then you'll see the number in it, then that part to that, which is really cool. You get to see all of that printed to the screen here. There they are. You can see each one of them is listed. So I'll stop jumping for a second. Stop jumping! You can see it's written 0 through 4. 4 is the last one on top because of the way it's ordered. And arrays are always ordered from 0 and up. So we have 5 in our array, so it counts from 0 to 4, which is a total of 5 entries. And they are currently all set to none. But now that we can see them, we can start modifying them. So we're going to set up a spot in here that checks for each action. All right, so I'm going to come in here. I'll do this after the fall animation, but before the gravity. And I'm going to say check if we're stuck. So what we're going to do that is we're going to first check the current action. So the current action is going to be set to whatever the state is. Okay? So whatever action we're going to get, it's going to be set to whatever our state value is. Then we're going to run our timer. We have our little action timer. So I'll say action timer, and we'll say minus minus. So this will start counting down the action timer. And we're going to say if our action timer is less than or equal to 0, we're going to do some stuff. So in here, we're going to check each one of our last actions and see if they are the same. If any two actions are the same, we're going to tell it to immediately do something else. So how do we do that? Well, first we have to consider that our last actions are an array. So we first need to write the loop that controls that array. So I'm going to say for our variable n, so var n, is equal to 0. So we're going to start at 0. As long as n is less than our action count, then we're going to continue to step through the array. Open some braces here. So that's going to be if last action, and remember this is an array, so we're going to put open our little braces on there, and we're going to put the little n inside there. So that n is going to check each one of these actions. So if our last action is equal to none, so if nothing has happened within the span of our timer, then our last action is going to end up giving, it's going to be given a value of whatever action we currently have. So last action n will be equal to whatever is in our current action. And then we don't want this to step all the way through. So if we were to write this right now, we were to run this, you would see it immediately update and be all of the actions at once. And you can kind of see that. If I run this, you'll see it happen. Our last action will immediately become all of the same thing. So there's last action, and now they're all idle. The reason they're all idle is we didn't tell this thing to stop. The loop says, yep, I'm going to just go ahead and loop through each one of these actions the moment I'm given this information. But we need to tell it to stop looping after one action has been given a value. So we're going to say break. So this is going to say, once an action has been assigned, we're going to break it. We're going to break this loop. So it's going to exit this part of the if statement here. And then it's going to return the control back to this for loop here. Once we're outside the for loop, we're going to update our timer. So I'm going to say action timer, and that's going to be set back to our value of 6, because that's what we started with here. So I'll just put a little comment that says reset timer. Okay. Now that we have, and of course we have our action timer being checked, so we're going to put that to our draw event here. Underneath our normal timer, we'll make a new line called action timer. So this will be 10 down, so 14. And this will be action timer. And we'll put that here. you'll see the action timer updating, and you'll see what loads into each one of those actions. Let's go ahead and see what we got. You can see the action timer updating, and of course it's all set to idle. So it's not getting what current actions we currently have. So we should be seeing each one of these populating for the next actions. Let's take a look at what's not happening. Everything in the code looks fine, so we'll go ahead and move our little guy over just so we can see the numbers. My guess is we're just not seeing the population happen. Let's take a look. So there we go. You can see it actually, a little bit of a tick, it populated. So what we're not seeing is it being re-updated for the next action, which is fine. We're going to do that next. But the population works. Let's go back to our enemy object. So now that we have the ability to check the action, we need to update each action individually. So to do that, we're going to create a new loop inside of our for loop. Loops and loops here. So what we'll do is we'll check for a new loop. We'll say for, and we're going to create a new variable called var I. And the only reason we're doing this is we can't have n be checked against n because they're the same. So we need to have a different value being checked against a different value. So if var I is equal to 0 and I is less than the action count, then I++. And we'll set up a loop inside of here. So the way we're going to do this is we're going to see if the last action we've done is the same as a previous action, then we're going to tell our character like jump out of the hole or whatever it is. So in this case, we want to see if our last action is not equal to certain things. So things that we don't want our action to be. We can't make a decision. Oh, make sure we put our brackets on there. So if last action is not equal to, and there are some things we don't want it to be checked. So we don't want it to check if we're none, right? So if no action has happened, then we don't care. We also don't want it to check if we're idle, because we can be as idle as we like. We don't want it to check when we're falling, because we can't change our mind when we're falling. And we don't want it to check when we're jumping, because we can't change our mind when we're jumping. So we're going to have it check all of those things and make sure that we are not any of those states. And then it's going to compare the actions together. So the first thing is, are we none? Well, if we're none, then nothing's going to really happen, right? So if we're not none, and last action n is not idle, and we're going to have a bunch of these ands. So after this second and, I was going to hit enter. So and last action n is not equal to jumping, because we don't want to be jumping. And, oops, make sure I do my ending quote there. And last action is not equal to falling. All right, enter. I'll do another and. So if we're not doing nothing, if we're not idle, not falling, and not jumping, and so all these have to be true in this case. Well, these would technically have to be not true. And then this one has to check. So now we're going to compare our last action to our other last action. But we can't do n versus n because they would be the same, right? So the way it would see it would be, it would see it like this. It would say last action n, and then we would want to check to see if it's the same as last action n. The problem with doing it as an n versus n is whatever this number is going to be the same as this number. So it's going to see this as last action 0 versus last action 0, or last action 1 versus last action 1. We don't want that situation to happen because the n will always be the same. So we're going to say last action n. We're going to see if last action n is the same as last action I, because I and n are not the same, so it'll check at different rates, and then we can do something. So if this is met, then we're going to do some stuff. So open brace, closing brace, and I have a red tick. I have an extra parenthesis. Take that one off. Okay, so if this condition is met, then we're going to want our character, in this case, if he's randomly going back and forth and he can't do anything else, then most likely you're just going to want him to jump out of the hole. So in this case, we're going to have him say state is going to be set to jumping. So he'll jump out of the hole. After the state has been set, we're going to have our last action, n, be set back to none. Okay, so if this happens and we find out that there is an action that's the same, we're going to have our character jump, and then we're going to reset all of them to none. Okay. Else, so we're going to have a little else here. So if this happens, it's going to reset them all to none. However, if none of them are the same, if there are no matches within this time frame, then we're just going to reset them all back to none. So last action n is none. So the reason we want to set them all back to none within this time frame is you could have a repeat of action. Let's say you take a few seconds, you walk left, you take a few seconds, you walk right, or whatever. You can do that again and again and again. We just want this to say if it's repeated the action within a certain time, which means it's kind of being frantic. It's stuck in some place and it can't make any other decisions, then we need it to run this thing and get it out of the hole. That's all it does. So if it's done in a certain amount of time, it'll do this. Otherwise, behave like normal. And if we run this, we should see our little guy move around. And if he gets stuck, he'll immediately jump out of the hole. So here he goes. And he checks, he's going to try jumping out of the hole. Now he can't get out of the hole here because he can't super jump forever. But you can see that he's trying. So if he were stuck here, he would be trying to get out. And you can see the timer, it's going. And if he actually gets up in here, he'll continue to jump out and out and out. But yeah, he's doing his job. Let's go ahead and move him back down. Let's put another one in here just to see what they do. Put one like up here. We'll see what our little enemies do. There they are. They're all kind of thinking. He's going to jump. Yay. So in this case, they're like, yeah, we're repeating an action a little bit too much, so let's try something different. And that's what they're doing. They're getting there and they're trying that jump to get out of the hole. Now, if they were in an open spot, they would succeed and get out of the hole here. Let's do that. Let's take these blocks off so you can see that. Go back to the room here, and let's move this block. I'll move this one like up here. There we go. You can see that they're stuck in the hole and they jump out immediately. Boop, boop. After it repeats a couple times, they jump out, which is really cool. So you can set these guys up and have them negotiate some relatively decent arenas, and they'll move around as if they're alive. And all it is just a basic logic. If you're stuck, if there's something ahead of you, do this. If you've done this a few times, do something else. And that's all they're doing. And then, of course, when you play the game, you'll turn the debug code off. You won't really have that running. But they'll behave. So if I go in here and I turn the debug code off, so my draw event, I turn this stuff off, it'll just look like I have a bunch of NPCs going around and doing whatever. Oh, just to show you to the point, if I turn off the draw self, because we have a draw event, if I turn off the draw self, they'll appear invisible. So we'll just run that real quick. See how they're not there? But they are actually there doing their job. We just don't see them. All right, we'll turn the draw self back on, and we'll run it again. So here they are. We don't have the debug code being displayed, but you can see that they're doing their thing. And they're going to walk around and try to jump over stuff. And it works. So hopefully this has been, I know this video is a little bit longer than most of them. Like anything that's close to an hour is kind of long. So sorry for the length, but there's a lot of stuff in here. And you can use this setup to make just about anything as far as your basic NPCs go without too much complexity. So hopefully this has been educational for you. If you guys have any questions or comments, you're welcome to leave them below. And yeah, happy gaming. I'll see you guys next time.